So let's develop the idea of a tangent plane quick. So equation of tangent plane. Alright, this is going to feel a lot like a Calc 1 exercise. So the idea is, here I've got some surface, right? That's an axis, that's an axis. There you go, surface, right? X, Y, Z. I would like to make a tangent plane to this thing. So maybe out here at some spot that's above a point down here. Maybe this is AB. Alright, let's start with just flat review. If that's AB, what are the coordinates for this point?
AB, F of AB.
AB, F of A and B? Perfect. Very nice. Good. Okay. Now, I want to know about the tangent plane here, right?
Mm-hmm.
So, when I remember a plane, right, that should look like what? Maybe, let's call it P for plane, as a function of X and Y, right? Okay. So, what are the pieces of this thing?
AX plus BY or something like that.
Okay, so there's a X slope, a Y slope, right? And a Z naught, some point that I'm starting at, right? Okay, so I'm going to say, all right, there's some Z naught, right? That's kind of an initial height for the plane. And then there's some slope in the X direction times something. And then there's slope in the Y direction times something. Right?
Yep.
Okay, so looking at this, what's your Z naught you're starting at?
F of AB.
F of AB, yeah, awesome. Okay, and then I'm going to add. What's your slope in the X direction?
Fx times x.
Okay, so you need
Partial.
F partial derivative with respect to X.
Right.
Where are you running that? Like, what's the
X minus A.
close?
Oh.
So where do you want to evaluate that slope?
Oh,
At AB.
Better be at AB, right? Because otherwise you'll be picking this slope someplace else. And this shouldn't be variable, right? It should be constant. You see that?
Yeah.
So that's me putting in this piece about, okay, if I make an X slice, right? Like this, I want this slope to agree. So there's my Fx at AB is that slope, right? If you wanted to fill in, oh, what's the run on that?
Delta E.
that would be X
delta.
minus A, right?
Yeah, that'll be
yeah,
X minus
that
A. Right? That's going to be like Sx times change in X, right? Okay, and then I need a Y piece, which is going to be what? Fy at AB times y minus b. So we're thinking, all right, if I'm going to make a plane, it's a starting height plus a slope in X times the change in X plus a slope in Y times the change in Y. And, you know, big surprise, I already know how to calculate all those things. You guys see this? This is a little bit like your equation for a tangent line in one dimension, right? In one dimension, you'd be looking at, you know, L of X, right? And that'd be
F
Y naught plus F prime at X naught times X minus X naught. You guys remember that thing?
Mm-hmm.
Yeah, this is the linearization. Yeah, so that's another, actually, maybe a good, instead of calling this a plane, we could call it the linearization. Remember, this thing's the first two terms out of the Taylor series, right?
Right.
So is this thing. Three-dimensional Taylor series get complicated, but in the first two terms, they're pretty easy. It's just a plane, and that plane is the one that contains these two tangent lines, right? that? Alright, cool. There's your equation.